morning, everybody. Who was in the workshop yesterday? Let's see how many people. Yeah. Okay. Welcome to Code Security Reinvented, navigating the era of AI. I really want to build to what we knew from yesterday. Let's see how this looks like. So, starting with a statement, AI in the IDE can help developers with security. It sounds like a bold statement, but I'll show you different cases, and I'm sure I can convince you. The first case is writing safer code. Let's start the other way around. I want you to understand how not to do so, how not to write safer code. So on the code you see on the right, just to keep things flowing and smooth, we have, I'm going to tell you what the problem is. Line 23, SQL injection. Let's try to detect that with AI. So I'm running here the prompt, list the security issues in the code and propose code to fix each of them. And we are using GitHub Copilot. It's a bit older version for those who are familiar with it. It doesn't matter, okay? At the top, we see that SQL injection is indeed recognized as a problem. That's accurate, yeah. But then you see passwords in plain text. That's a hallucination. This is something that our code doesn't suffer from. So hallucination is the #1 thing you are gonna get should you rely on AI to detect issues. The #2 I wanna show you is the following. I have the code from yesterday imported on the left. You see season 1 and 2. Season 3 is not important in this one. And I'm running a very similar prompt with the hashtag codebase in order to have my whole codebase, the 10 problems this codebase is suffering from, in the context of Copilot. And when running that, Copilot came back with 8 problems. Somebody can say, so do we have 80% accuracy? I wouldn't say so. But some of these issues, I've seen them for the first time being reported. Just like prototype pollution in number 6. Prototype pollution occurs when you have a parent method injecting or maliciously giving information to a child method. That caught my eye. And I said, I'm a security specialist and I'm seeing prototype pollution detected by AI for the first time. And you know, let's open the specific file that was there, put it in context. Here you have it, code.js, and run the exact same prompt, right? And the results do not have pollution inside. So this shows you the second problem that we suffer from, which is non-determinism when it comes to detecting issues with AI, or relying on that. However, I said, well, let's change the model. Maybe OpenAI didn't do as good job as Anthropic. Changing the model, same stuff. Pollution didn't come up, as you are gonna see now. And I'm running my prompts for one time every time. Some minor HDMI issues, so as you see, pollution is not there. Now, what you had there was, how can I fix that? And this brings me to something that I really want you to take away from today. In cybersecurity, we don't have a detection problem. We have a fixing problem, okay? So we have so much tools for all these years that give us so much information about problems in our code. False, positive, whatever, we just have the info, okay? But we don't have the skills. We actually have one application security specialist for every 100 developers. But with AI, we can fix stuff as long as we are careful enough and we read the code that AI suggests and we make sure we don't introduce other problems, okay? So when it comes to fixing, the results are much higher quality. There are filters to prevent vulnerable stuff from being suggested. As long as you don't rely on those and you read the code, you are in a good shape. Now, I want to show you the same stuff, but with agent mode enabled, because of the idea that with agentic AI, we have, for example, an AI agent that is security specialized, and then an AI agent that is specialized in writing JavaScript. And in this specific case, we had the agent actually detecting the pollution, as you see here in #2. And at the same time, the fixes were good. But you shouldn't today, 19 of November 2025, rely on AI for detecting issues. This is because while AI can help minimize the security gap, it's not here to replace security testing. The security testing we use is built for security testing because it has taint tracking capabilities, data flow capabilities, while the AI we have is predicting the next keyword, either English keyword or another language, or a coding keyword, is not good at detecting stuff. So as developers, always follow good security hygiene. AI shouldn't be your only, as you see with caps, and only is the keyword here, safety net. MCPs to the rescue. So I've seen the previous sessions. I agree with the presenters. I want to go a bit deeper though, okay? So for those that are not familiar, the MCP is a standardized protocol so that the agent, the AI model, can exit from the training that was done and get access to real-time data, get access to server-side information, such as our accounts. When we detect issues with AI, as we've seen in practice, yes, we suffer from non-determinism. It may miss, it may hallucinate, but at the same time, we have a unique opportunity to model things with natural language that we don't have with tooling such as static application security testing, for example, that on the contrary gives us high confident results that are deterministic. And here I want you to notice what we have at the top. What about the security MCP server that combines both ideally? We are working on that, and I'm in the position to say that the user experience is not nice. We have to improve on that before we release anything like that as GitHub, and I can go in more detail. The MCP protocol is synchronous, right? So for a static application security testing tool, for code scanning, for example, when we try to use it, the user experience is slow, is really bad. And then we try to put that in on the ID level and then have an AI agent commenting on the results or helping the user with the result, orchestrating different tooling. It's not nice. It's not working. That's a goal, but we are not there yet, okay? It's just something ideal. As developers now, when it comes to these tools in action, for me personally, as a security specialist, it's hard to trust an MCP server that I don't use already. For example, if I use Figma, it makes sense to trust their MCP server because I already use them, right? And why I don't trust them? First of all, I've seen a lot of MCP servers that are asking for overly broad scope. Too much. My stuff in the ID is gonna get exposed on the outside. Then indirect prompt injections, as you saw from yesterday, 100% possible. Yesterday in the workshop, you were typing the prompt, right? Imagine when I have a list of prompts ready to attack you from the inside. That's the top two things I would say. Then a lot of MCP servers here and there. The VS Code tried to have its own registry. GitHub came up with its own registry as well. Have a look at those. When it comes to security, I've only seen two servers there. The one from Codacy, which is a company, and the one of GitHub. The one of GitHub is not specialized in security, but there are some functions you can use. Like for example, this one, code security, and the top two, the last two, secret protection and security advisories. The way you use them is that you are in the agent mode and you use one of those functions. So the MCP server is going on the server side. You should be authenticated and is taking stuff that were server side as well. For example, the alerts that your code has generated, the secrets that your code has leaked. And what you get from that is that you can have a chat about it with your AI coding agent. At the same time, you can save some time by getting a security posture being summarized for you, next steps, and so on. Here, the disclaimer is that you can get some stuff to get started, but don't expect that Copilot is like the security expert, right? It's a coding assistant. The information is good. Use it to save some time. Use it to get stuff on the ID level. It's really good at that because the information is structured, is on the server, or in a pull request, is very structured to the point that you shouldn't expect hallucinations. Now, Take better informed decisions when it comes to your supply chain. This is something that maybe becomes an MCP server in the future. It's something we worked on in the past months. And I'm here to give it to you for free as all the other stuff we see today. So you can speed up your research for the community health and security of a package before this package becomes part of your supply chain risk. Every time you introduce something in your code base, you increase your attack surface. Let's be honest now. How many of you spend more than 10 minutes, 15 minutes to decide on a package you are going to introduce in your code? Let's be honest, right? Yeah, okay, nobody. Perfect. So this one, we try to do it at the top here. Tell me about the community health and security of the Python package Welly. What you see is a structured tick or X or be alerted for, different categories. So you have an executive summary, and then you can visit the URLs that we looked for. And how we did that, we put together a set of instructions that you can access in this URL. Is 2 or 3 different files. You can modify them to your liking. The 2 or 3 people that worked on that worked really well to avoid hallucinations. I extensively tested that. It's good. It's working. Many people are asking me, but why it's more than 1 file? Because this is how we achieved a quality that makes me confident to show you this publicly today. With 1 file, we just didn't do it. Maybe in the future. So just copy those files, put them in your ID level, ask those questions, make better decisions when you introduce stuff, because later on, you get problems with your supply chain. Next one, security guidance. We run a program internally called Secure Open Source Fund. We give $1.25 million, which is 10,000 to 125 projects. And every single open source project that we helped came with the same question, which was, and you are going to see it now on the web interface of Copilot. I'm in the web. I'm inside a repo that I don't maintain, such as Bootstrap. The question is, how can you hack my project? What's my attack surface? What are my problems? And these 125 projects are lucky because they get us to have them answering that question. They get the money. But what about all the other people in this world that don't have access to these specialists and so on? So the number 1 question people ask for projects they use or for projects that they don't use, such as Bootstrap that I don't maintain, it's a project that I'm considering, for example, in my supply chain, is how can somebody hack me with that? As a security specialist, I will have to read millions of lines or thousands of lines to come up with a short list like this one, such as, for example, be careful when you use the sidebars because they might have the option or the problem of cross-site scripting because you know they have user input and so on. Having this short list gives you the chance to again decide about a code of somebody else. Should you trust it? How you are going to use it? And it's really good because people are having this question. Now, a lot of developers find fuzzing as something that they want to do because, you know, code scanning, they can get it. They can have their code being read. But fuzzing is an outside-inside approach, right? When something is public already, imagine just a normal email and password field. If you put like 1 million inputs to that, maybe you make it become slow. Maybe you make the system to have undesirable behavior. If you want to use an AI coding assistant to generate something regarding fuzzing, for me, you get 2 different options that are really strong. The first thing is the fuzzing automation / harness. For example, create a system for me that is gonna get inputs and is gonna fuzz something that I want to fuzz. And as a security specialist, this prompt here, can you generate the fuzzing strings, is where a lot of security engagements get slow. They get bottlenecked because the security specialists have to come up with a lot of inputs that have to be malformed or they have to be very long or hacky stuff. And for somebody that is not a security specialist, this boilerplate code is really useful. And you know what's another thing that is really useful? This blue text at the end, that is auto-generated. It's designed to keep the conversation going, and it has helped me so many times when I just didn't know what's next. Not for security, but for other developer-related stuff that I just don't have too much experience. Then you can get tailored answers. This is more on the training side, and it's useful because here we know that our code is suffering from SQL injection. This is a very easy injection so that everybody can understand in line 23. But in reality, in the real world, when it comes to cybersecurity, you can have dozens of ways that a problem occurs. There are dozens of variations of SQL injection, for example. And as a developer, maybe you don't get to understand, recognize everything by default or straight away. What you can do is that you can get specific answers or education or examples with coding on the specific variant of the vulnerability that your code suffers from. This is also helpful to me because when I studied about vulnerabilities, everything was theoretical, and it doesn't mean that because I understand it in theory, I can recognize it in practice. So this is something that connects the two worlds, theory and practice, when it comes to dev education. One of the last topics of today is fixing security issues. As we said in the beginning, in cybersecurity, we don't have a detection problem, we have a fixing problem. In the past, let's go back. When you have found a problem, you know about it because maybe somebody hacked you, or you have penetration testers, or you have people reviewing code. The best practice is to have code scanning in your CI/CD, of course. And the old experience before AI was that, you see the problem that you get alerted for in your server side, for example, whatever, SonarQube, GitHub, you name it, okay? Then you see the problem, you go back to your ID, you fix that problem, you push the code again, and you see if the alert is there or not. This is past. Autofix, which is free for open source, you can test it in the code we had yesterday that I'm going to provide again. With Autofix, you fix this problem straight away with AI on the ID level. Within GitHub, we fixed 600 vulnerabilities in 2 weeks, bringing the fix rate from 50% to 100%. Our clients have reduced the time to remediation, which is important because the more time they need to fix stuff, they were fighting more internally, they had competing priorities internally, and so on. So this is the old experience that I told you about. You get in code scanning, you see the alerts, you click in the alerts, you read what they are about, you go back to your code, you try to fix that, you push again, no. The new stuff looks like that. So this is a pull request that I have pushed. I pushed a feature, right? And the detection is happening with a code scanning tool. We are not relying on AI to detect. The best practice is to use the expert tool to detect. But we use AI to propose fixes for that. So you get the explanation here. Come on. Yeah, you get the explanation here. Exactly what the problem is, where it occurs, what's the source of the vulnerability, what's the sink of the vulnerability, which means where it's really being executed. Let me go back to that. So I'm on the navigation again. Okay, so basically what you are gonna see here is code in green color. That is the usual code suggestions from GitHub being suggested to you from AI on the PR level. This code that is suggested to you is guaranteed to remove the alert, but you don't have to commit that code if you don't want to. You can edit that code inside the PR, not even in your ID, straight away, without even opening code spaces, but you can open if you want to, and then you can remove that alert. So in summary, today we covered 6 different ways that today you can use AI to ship more secure code. The number 1 was to write safer code. Remember always that you shouldn't rely on AI as your only safety net. Don't use it to detect stuff, use it to fix stuff. Always read the code before. That is suggested to you. MCP to the rescue. We saw that right now you can access server-side stuff and use those with AI. We are not where we dream to be with MCP yet, but I hope we can get there. Supply chain decisions. You can make better decisions when you have a structured way with AI to get the answers you want to. If you don't want to rely on that, visit the URLs yourselves. Get tailored answers is all about getting the guidance and education that is tailored to the variant of the vulnerability your code is suffering from. Security guidance, very similar to the supply chain decisions. The difference is that you are going to get a short list of something you should be careful of in case you use a code you are not familiar with. Find and fix security bugs. Copilot Autofix is something that is going to help you in the same way that has helped us internally and other open source projects becoming faster. Yesterday, we played what is in this repo here. gh.io/secure code game, abbreviated as SCG. Use that repo as the playground to try what I've shown you today for free. Have your own experience before trying anything in the code you own and you care about. And for those that were not in the workshop yesterday, this is a repo with 3 different seasons. We got amazing feedback from yesterday. Was it fun? Yes, exactly, it was. So for those that didn't play, you can have your own game there. And for those that played, always remember that you have season 1 and 2 as well. And you can also be part of our community by contributing, following the contribution.md. That was me. I love creating content for developers and try to use a language that is more developer-friendly in cybersecurity than what many other security professionals are using, trying to make developers, try to add value to developers to understand the vulnerability patterns and so on. You may have seen me in the Instagram of GitHub or Microsoft creating reels, trying to raise awareness, or in different conferences such as this one. Thank you so much. You've been a fantastic audience. I'm here for your questions, and I'm also around in the conference. Thank you so much.
Thank you, Joseph. Yeah, inspiring as always. Thank you very much. We might have time for one question. If somebody wants to ask a question, and I'm sure you can find Joseph later if you want to. So, no questions? Everything clear?
Happy days.
Good job.
Thank you.
All right.